Hey everybody, we are going to now look at some interpretation of this data. We can see our table here that I created with my experiment. You should have one that's fairly similar. Your numbers might be a little different. We then took that data and plotted it on this graph, and now you are probably looking at some of the questions, and some of the questions are these. So I'm going to now try to fold this paper up so we can look at these questions and answer them and be thoughtful about this. So some of our questions. Suppose you could split layers in half. What breaking weight would you predict for 2.5 layers? That was question for part C of this. So if I'm looking at this, it's really hard. I can't necessarily say, oh, 2.5 layers is going to be 25.5 pennies for me. But I mean, technically, yeah, it is. Like, based on what I have here for my data, if I'm looking at this, I have a general trend. And I drew a line here between my data points. And this line, while it's not accurate, there's technically an accurate way to do this, and we're going to calculate the accurate way to draw a trend line. While this line isn't necessarily accurate, what I can do is I can look at my data and sort of look at how it's traveling, and yours might be bent, yours might be like dropping off at the top and becoming flat, but mine ended up creating this really nice sort of increase, positive increase pattern of about 10 pennies each time. And what you can do is you can sort of look at this trend line and say, okay, if I could split paper in half, what would the number of pennies needed to make that piece of paper break? How many pieces of paper, how many pennies would I need? According to this line, I would need about 25 pennies to make that happen. Now, as I look at this, 25 pennies is what I got at layer 2, or like 2 layers thick. But 3 layers thick, I got 26. So clearly this, maybe my folds were super strong, or maybe I was more careful about placing pennies in this second layer than I was the third layer. Either way, everything sort of caught up and became a little bit more consistent as I got to the 4th and 5th and 6th layers. And so 25 pennies, based on all of this data that we have here, seems fairly reasonable. So I want you to make that same sort of prediction. At 2.5 layers, what does yours look like? Last but not least, there's a final question on this that I want you to reflect on. Why would your prediction for this 6th layer, that my prediction was 63. If you go back and watch my video, I had a prediction of 63, and what I got and ended up being 62 pennies broke 6 layers of paper. Now, why might my prediction be different than the actual data? Well, let's talk about that. I mean, technically, how you folded your paper might have played a factor in that. How you placed a penny might have played a factor. Now, 62 to 63, I'd have to say that is a pretty darn reasonable margin of error. 62 to 63 is really close. Like, I did a really good job of predicting. I was really hoping for maybe this to be blown out of the water and be like 67 and then totally destroy what I thought. But, I mean, I did a really good job. So, given that information, like, I mean, 63 is well within the possibility of that prediction, so I feel like I'm pretty good there. However, there are a lot of different variables with this particular experiment. How we fold paper, how strong the paper is, how many times this paper broke when you were doing this. Did you try one of these more than you did another? Maybe at 3 you didn't accept your data like I did, and at 3 you decided like, no, I'm just going to make these like creases really strong, and I'm going to try to get a lot bigger number here. I don't know. Perhaps you were more accurate with your penny placement. Maybe you actually used a cup, whereas I didn't. I don't know what it might take, but there's a lot of different factors that could really lead to a lot of different errors in our work. Regardless, that's what I want you to think about. We are really, in this unit, we are going to be looking at real life data and taking that real life data and trying to make sense of it and say, is there a relationship between, in this case, the thickness of paper and the number of pennies that I put on that paper before it breaks. Is there a relationship between the number of crows that sit on a power line on a Monday at 9 a.m.? Or is there not a relationship there? Is there a relationship between the number of police officers who buy donuts on a Tuesday than other times? We're going to look at real data and ask questions. Are there relationships that we see? And in those relationships, hopefully we will see trends or not, and we can make predictions with those things. Thanks for watching. Make sure you do the exit pass, and I hope you do well. I'm not going to try to trick you on the exit pass, so attempt it. See how it goes for you. Thank you for watching, and I will talk to you later. Bye.